Hi guys, today we are going to be learning about 4.1 classifying triangles as well as congruent figures at the end of this. So by the end of today, you guys will be able to classify triangles using their side lengths and angle measures, as well as write congruent statements and find congruent angles and sides. So this first part should be fairly easy. You should have learned it like back in elementary school, middle school, classification of triangles and angles. An acute triangle has 3 acute angles. An equiangular triangle has 3 congruent acute angles. That means they are all 60 degrees because they have to add an equal 180. And then the obtuse triangle has 1 obtuse angle and the right triangle has 1 right angle. So our vocab here, an acute triangle is a triangle whose angles are all acute. An obtuse triangle is a triangle with 1 obtuse angle. And an equiangular triangle is a triangle with 3 congruent angles, specifically all 60 degrees. And a right triangle is a triangle with 1 right angle. So for our example here, you guys are going to classify the triangles as acute, equiangular, obtuse, or right. So this first one, it is actually 2 things. Because they are all 60 degrees, this is an equiangular triangle. And they are all acute angles, so it is also an acute triangle. The second one, because there is 1 obtuse angle, this is an obtuse triangle. It might be a good idea to review angles. So acute angles, these are any angle that is smaller than 90 degrees and bigger than 0 degrees. So the degrees have to be between 0 and 90, not including 0 or 90. A right angle is 90 degrees always, and an obtuse angle is anything between 90 and 180 degrees. So if you couldn't remember those, obtuse between 90 and 180, right is exactly 90, and acute is smaller than 90. Okay? So you try. Go ahead and try these next 2. Go ahead and pause me and then pick me back up once you've tried. Okay, so for this first one, the frame of the window design is made up of many triangles. This is going to be this triangle right here. ACD is this triangle. And that is made up of an obtuse angle because there is 1 obtuse angle here. This is called an obtuse triangle. The other one I did have highlighted, but then I accidentally just erased it, is this right triangle here, ADE, because it is a rectangle. We know that is a right angle, so this is a right triangle. Okay, from that angle. All right, try number 2. Okay, so for number 2, it says classify triangle XYZ as acute, equiangular, obtuse, or right. So put your pencil on X, trace to Y, trace to Z. This is the triangle we are looking at. Now I have this being a right triangle because if you take 40 degrees plus 50 degrees, you get 90 degrees, which is a right angle. So it's a right triangle. Okay? So classifying them should be pretty easy by its angles. We can also classify triangles by their sides. So you have something called an equilateral triangle, which has 3 congruent sides. An isosceles triangle has 2 congruent sides, and a scalene triangle has no congruent sides. So if we look at our vocab, an equilateral triangle is a triangle with 3 congruent sides. An isosceles triangle is a triangle with at least two congruent sides. And a scalene triangle is a triangle with no congruent sides. So, for example, example 2, if point Y is the midpoint of Vx and Wy is 3.0 units, classify the triangle VWY. So we're looking at this triangle here. We need to say if it's equilateral, isosceles, or scalene, and explain our reasoning. So we have to deal with midpoint. We know the whole distance of this segment here, Vx, is 8.4. That means half of it is going to be 4.2. Now, compare the side lengths of this triangle, 4.2, 4.5, and 3.0. Because none of these side lengths are the same, this is a scalene triangle. Okay, and just say to explain, so this is because no sides are congruent. Okay, you guys go ahead and try this next one. All right, on this one it says, if point C is the midpoint of BD, classify triangle ABC, which I do have highlighted in green, as equilateral, isosceles, or scalene. So once again, we can work with the midpoint since C is the midpoint of the whole segment, BD. Each little piece is 1.7 units. You will notice that in our green triangle, we have these little hash marks. I hope you recall that that means congruent. So the right side there, the kind of top right side, is also 1.2. Meaning, because two sides are 1.2, we have an isosceles triangle because two sides are congruent. Okay? So for example 3, we are going to find the measure of the sides of the isosceles triangle with triangle KLM with base KL. So when it says base, that means it's one of the not congruent sides, or it's the not congruent side, and the other two are our congruent legs. So KL, base, not congruent. The other two are the legs. They are congruent. So to find the measure of all the sides here, we actually know that LM is congruent to KM, so we can set these segments equal to each other. So I say 4D minus 13 is equal to 12 minus D. And then I just go ahead and solve. So I add 13 to both sides. And then I'm going to add D to both sides. I get 25 equals 5D. I go ahead and solve for D. Oopsie again. And D is equal to 5. Okay, now that isn't my final answer. I know I did put a box around it, but it wants me to find the measures of these sides. So I need to plug this in. So if I want to find KL, the equation for KL is D plus 6. Since I know D is 5, I'm going to say 5 plus 6, and KL is equal to 11. I'm also going to do the same thing with KM. KM's equation is 4D minus 13. I know D is 5, so 4 times 5 minus 13, or 20 minus 13, which is equal to 7. Now, I do know LM has to be congruent to KM, so I could go ahead and just write that answer out. LM is equal to 7. I can also quickly check it if I really want to, make sure I did the work right. So 12 minus D, or 12 minus 5, which is indeed 7. So we did it correctly. Good for us. So I have my side lengths here as my solution. You guys go ahead and try this next one. It is an equilateral triangle this time, and I want you to draw a picture to model the triangle. Okay, before I solve, I want to show you my picture. So I do have an equilateral triangle. That means all the sides are the same length. And I labeled A, B, C on each vertex, and then I wrote in where each function went. So like 6x minus 8 is AB, so I wrote that there. Same thing with BC and AC. Okay, now you will notice I put some little stars over here. We picked two to set equal, so two sides, not all three. Since they're all congruent, you can pick any two sides to set equal. And then once you solve for x, you only need to solve for one side since they're all congruent. So go ahead and do that, and then I'll show you. Okay, so I went ahead and set AB and BC equal to each other. You could have also set BC and AC. It doesn't really matter. No matter what, you'd get the same x value of 3. Now, as I was saying before, since they all have to be congruent sides, you only really need to plug this into one of the three equations to get the side length for all three sides. If it was a scaling equation or a scaling triangle, you couldn't do that. But because it's equilateral and we know they all have to be the same length, I'm going to set it equal, or solve for BC, I should say, because it looks like the easiest one. So I'm just going to plug in 3 for x, and I get that BC equals 10. Now, if you're a person that really likes to check your work, you can go ahead and solve for the other two sides and make for sure that you get that every side is equal to 10. I do also need to write out all the sides as well. So I only solve for one, but I do need to make sure I answer all of the question. And there we go. So that's part 1. Naming triangles by either side length or angle measure. I will point out way up here that I do want you to write the word triangle afterwards, because right angle is a thing. The word right is a thing. Obtuse angle is a thing. Obtuse triangle is not exactly the same as an obtuse angle. That's why I want you to write the word triangle every time. Okay? So don't just write obtuse, because I could think, oh, obtuse angle, not obtuse triangle. Okay? Anyway, we can name by angles, we can name by sides, we can do some solving. Now we are going to look at congruent triangles and congruent shapes as well. So you guys will be able to name and use corresponding parts of congruent triangles. So our vocab here: if two geometric figures have exactly the same shape and size, they are congruent. In two congruent polygons, all the parts of one polygon are congruent to the corresponding parts. This just means the matching parts of other polygons. Now, I'm going to use the term corresponding parts a lot. It's just as buddy, it's partner, it's match. These corresponding parts include corresponding angles and corresponding sides. So you're going to have to find these corresponding angles and sides a lot. So for example, we've just got a little diagram here, some pretty silly shapes, honestly. Because all three of these are the exact same size and shape, they are congruent, okay? They're just rotated, but that's totally fine. These guys are not considered congruent. They're actually something called similar. Number 4 is bigger than both 5 and 6, so they are not all congruent, although maybe 5 and 6 are congruent themselves. So the definition of a congruent polygon: two polygons are congruent if and only if their corresponding parts are congruent. So you'll notice they have marked every angle or every side as congruent to a buddy. So like AC is congruent to KH, which they have written here. So on and so forth. Because it is a triangle, or these are triangles, you have 3 pairs of corresponding sides and 3 pairs of corresponding angles. Now, our congruence statement down here is really, really important. The order here does matter, okay? So because I started on A, and then I traveled to B, and then I traveled to C, notice how this is like a double tick mark, single tick mark, triple tick mark? You have to do the same thing here. So we have to start on H, then travel to J, then travel to K for a double tick mark, single tick mark, triple. Okay? So your congruent statement can tell you a lot of things. Like notice because A, B are first and H, J are first, they are corresponding sides. Or because C and K are last, they are corresponding angles. So this is why it is really important to make sure you get that order correct, because you can tell corresponding sides and angles just from the congruent statement. And then the last thing on here, it says the phrase if and only if, and the congruent polygon definition means that both the conditional and its converse are true. So if two polygons are congruent, then their corresponding parts are congruent. So if you have two congruent polygons, or triangles mostly for our case, you can state that any other pair of parts of it is congruent by corresponding parts of congruent triangles are congruent, or we usually say CPCTC. Now, it takes you a minute to get that down. I would probably think of this for now, so you know what CPCTC actually means. Okay? So for our example here, these first few, we're just going to be writing out a bunch of congruences. So we are going to show that the polygons are congruent by identifying all the congruent corresponding parts, then write the congruence statement, okay? Now, we're just assuming that these two pentagons are congruent. I'm going to go ahead and mark their congruences. So if I zoom in here, I'm going to do single tick marks on A and R, then I'm going to do double, triple. It gets kind of difficult when there's so many of them. And then 4. And notice, guys, that these could be rotated. This one's a really simple example because it's not rotated. They just are sitting exactly how they are congruent. Okay, then I'm going to go around and mark these sides congruent. And now it's a little easier for me to visualize my congruent angles and my congruent sides to write these out. So if I look, angle A and angle R are congruent, so I can just say angle A is congruent to angle R. And then I keep going. Angle E is congruent to angle Q. Angle D is congruent to angle S. Angle P is congruent to angle C. Remember, this is the congruent symbol. A equals with a squiggly on top. And then angle B is congruent to angle T. Okay, as for the sides, same idea. Segment BC is the same length as segment TP. Keep going. Segment BA, congruent to segment TR. Segment AE is congruent to segment RQ. Segment ED is congruent to segment QS. And lastly, segment SP is congruent to segment DC. So you need to have as many congruent side pairs as there are sides and as many congruent angle pairs as there are angles. And then for your congruent statement, you go ahead and say polygon, since this is a polygon, not a triangle, and write them in order. Now, it doesn't have to be alphabetical. Like this first one, I'm going to say A, E, D, C, B is congruent to polygon. Now, because I started with single hash mark, and then double, triple, 4, and 5 hash marks, I'm going to write out my order the same on my other polygon. So that would be R, Q, S, P, T. Okay, so our order matters there. That means if I go in here and look, AE should be congruent to RQ, which it sure is. Okay? So let's do another one. Write a congruent statement for these guys. List all pairs of corresponding parts. So for the angles, same idea, although these are rotated. So you can't just like look side to side. You have to actually look at the hash mark. So angle A is congruent to angle W. Angle B, is congruent to angle X. Angle C is congruent to angle Y. And angle D is congruent to angle Z. Then I look at the sides. So I'm going to say BC is congruent to XY. AB is congruent to XW. AD is congruent to WZ. And lastly, CD, segment CD, I should say, is congruent to YZ. Okay, now I do have to state my congruent statement for my polygon. So I have polygon, and I'm going to say A, B, C, D, although these don't have to be in alphabetical order, is congruent to polygon W, X, Y, Z. They just happen to be this time. All right, you guys go ahead and try this one with the triangles and the actual degrees and lengths instead of the tick marks. All right, so I went ahead and wrote out my congruent angles and my congruent side pairs, and then also my congruent statement. You might have noticed that, at least I personally think this way is a little more difficult when they don't give you the tick marks and they just give you the measures. If you really want to, you can go ahead and add in the tick marks for like quick reference. Not super necessary if you don't want to. You can obviously tell just by the numbers, but that can be helpful for some people. Okay? So next we're actually going to use this idea to do some solving. So it says in the diagram, triangle ITP is congruent to triangle NGO. We're going to find the values of X and Y. Now here's the deal. I told you that these congruent statements line up and help us know what is congruent to what. So in this case, we need to find segment NG, which is the first part of our congruent statement. That also means that it is congruent to IT because they share the same spot in our congruent statement. So with that being said, I can set those two things equal to each other. Now I can't really get very far right now because this has two variables in it and that isn't really able to be solved for a number right now. So I'm going to look at my other part, my O. So angle O has to be congruent to angle P. So these two are congruent angles. Because angle O only has one variable, I can go ahead and solve for Y first. So I will add 14 to both sides. And when I finish solving for Y, I get that it equals 9. Now, like I said, I couldn't solve the first one over here to start because I don't know what Y is, but now I do. So I go ahead and plug that in. And I finish solving. So my X is going to equal 25 and a half. Okay, now if it did ask us to find the actual side lengths or the actual angle measure, well, first of all, you already know what they're congruent to, so you wouldn't even have had to have solved. And secondly, if you wanted to, you could just plug it back in to check. Okay, so there's X and Y. You guys go ahead and try this next one. Okay, so once again, based on our congruent statement, we have these triangles, FHJ, congruent to triangle HFG, and these can tell us what parts of our triangles are actually congruent to each other. So F and J, we need to solve because this is where Y is in our problem, 2Y minus 3. They are separated in the congruent statement, but that's okay. They're still a segment, FJ. that means HG in the other triangle is congruent to it. So I went ahead to solve for y, and y is equal to 2.75. The angles in this case are a little different. They're not just separate little pieces like they were before, like P and O. This time you actually have to think about the angles, and we find that angle GFH is congruent to angle FHJ, just kind of like our congruent statement here, okay? So I went ahead and set those equal to each other because they are congruent, and when I solved for x, I got 4.5. Okay? So the third angle theorem we kind of actually learned already earlier in the year, a little bit in a different context. It says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle are also congruent. Since we know all triangles add an equal to 180 degrees, if two of the angles already are congruent to each other, that means the third one must be the same as well. So we are going to try a few proofs. We have to prove that these triangles are congruent. So I'm going to walk you through them based on the givens. There's not too many steps, and hopefully you can kind of see where we're coming from. So, given angle L is congruent to angle P. Already there. Segment LM is congruent to segment PO. LN is congruent to PN. And MN is congruent to OP. So, we need to get all angles and all sides congruent to each other currently. Eventually, we're going to get an easier way in a couple days. So I started by writing out my givens. Notice it's broken into two steps. You don't have to necessarily do that. I then see something really, really quickly. I know vertical angles exist. So I can go ahead and say angle LNM is congruent to angle ONP. Okay? So this is just vertical angles theorem. Theorem. Gotta spell it correct. Okay, so we have our vertical angles theorem here. We're gonna use that a lot, so get used to seeing vertical angles theorem. And then that new theorem we just learned, our third angles theorem. Notice we already have two pairs of angles congruent. We just need our third ones congruent. We have a new theorem for that. Angle M is congruent to angle O by the third angles theorem. And then, I should have said this at the beginning, but we are trying to prove that these two triangles are congruent. So, because all corresponding parts of these congruent triangles are congruent, we can go ahead and say that LMN, triangle LMN, is congruent to triangle PON. And I'm going to use the shorthand by CPCTC. And since we finished it, we proved what we set out to prove. I put a little box there to signify that I am done. Okay, now eventually CPCTC is going to mean a slightly different thing just when we get a little further, but right now it's just stating that we have three pairs of congruent sides and three pairs of congruent angles. So because the corresponding parts are congruent, the triangles are congruent. This next one, we have a few given things. They're already written out for us, thankfully. Let's check that they're all marked. So QN is congruent to OP, and QP is congruent to ON. We also know that the angle Q is congruent to the angle O, and we know the angle NPQ, this angle here, is congruent to the angle PNO. So they're already written out for us. That's everything that was given to us. I would highly suggest marking up any diagrams that you are given to make sure everything's there. We have something that we haven't really used a ton yet, but super handy when it comes to proofs. It is called the reflexive property. If an angle or a side is shared, like this one right here, we need to state that it is congruent to itself. I know it seems super funny to state that something is congruent to itself, but we have to be super thorough. We have to make sure we state everything that we see to make sure we covered all of our bases. Oh, that's not what I meant to write here. I meant to write reflexive property. So we talked about reflexive property and symmetric and transitive property a while ago, and actually quite a few times. And this is one of the cases where we can use it. The reflexive property, especially. And then once again, we already have two sets of angles congruent. So we can go ahead and state the third angle congruent by the third angles theorem. So I'm going to say that angle QNP is congruent to angle OPN. And then because I have all pairs of sides congruent and all pairs of angles congruent, we can state the triangles congruent. And once again, this isn't the greatest form, but it is by CPC/TC. And we're done because we proved our triangles congruent. So hopefully you guys don't feel like proofs are too crazy yet. They aren't really super crazy. We'll keep walking through them. You'll notice on our last page then, it is just a little helpful hint about reflexive property of triangle congruence. So if you have one triangle, it is congruent to itself, I should say. The symmetric property is if you have two triangles, you can state them congruent either way. And for the transitive property, if you have three triangles and say these two, this triangle and this triangle are congruent, but you also know that this triangle and this triangle are congruent, this one and this one also have to be congruent, is what transitive property is saying. Okay? You can just skip the middle step, basically. And that's all I have for you today. I hope you have a great day. Bye.